All right, hi everyone. Welcome to the example video for 10.2. In this video, we're going to look at assigning oxidation numbers, determining what is oxidized and what is reduced, and also looking at the oxidizing and reducing agents. So just remember that to determine oxidation or reduction, it's all about the number of electrons. So there are two ways that you can remember. You can remember oil rig or Leo Ger. Either way is fine. It means the same thing. I usually will catch myself saying Leo Ger because that's what I learned in high school. All it means is that when you lose electrons, it's oxidation. When something gains electrons, it is reduction. So if you look in this graphic down here, zinc goes from an oxidation number of 0 because it's solid zinc, so it's elemental zinc, to +2. So to go from an oxidation number of 0 to +2, it becomes more positive, which means it's losing electrons. So zinc is oxidized here, and then H plus is going from +1, so each hydrogen is going from +1 to 0. And so +1 to 0, it would have to gain electrons to go from +1 to 0, and so H plus is reduced. So when we're looking at agents, so we're looking at what is called a reducing agent and an oxidizing agent. So reducing agent is also called a reductant. So remember that oxidation cannot happen without reduction, and reduction cannot happen without oxidation. And so the reducing agent is what helps the reduction process. So the reducing agent is what causes reduction, which means it will lose the electrons for whatever is being reduced to gain. And so the reducing agent itself is actually what undergoes oxidation. So whatever substance undergoes oxidation is helping the other substance be reduced, and so it's called the reducing agent. And then likewise, the oxidizing agent is what helps with the process of oxidation. And so if it helps the other substance become oxidized, that means that substance itself must be reduced. And so that substance gains the electrons. And so the oxidizing agent, which is called the oxidant, is also what undergoes reduction to help the oxidation process. So what we're going to do is we're going to look at the examples that are in the notes. So example 1 says to assign oxidation numbers, indicate what is oxidized and reduced, and then indicate what is the oxidizing agent and reducing agent. So the first thing that we want to do is assign oxidation numbers to every substance. So you have to go back and you have to look at the rules for assigning oxidation numbers. So calcium solid, that's elemental calcium, that will have an oxidation number of 0. H plus, because it's an ion, the oxidation number of the ion is the same as the charge. Now the coefficient is just to make sure that charge is balanced. But each H plus will have an oxidation number of +1. Ca2 plus would have an oxidation number of +2 because it's an ion. And then H2, that's hydrogen gas, that's elemental hydrogen, that will have an oxidation number of 0. So once you have the oxidation numbers assigned, then we have to look at what is being oxidized and what is being reduced. And the reactants are always what are oxidized or reduced. So calcium goes from 0 to +2. So if calcium goes from 0 to +2, it's becoming more positive, which means it has to lose electrons. And so calcium is oxidized. It is losing electrons, so it's oxidized because it goes from 0 to +2, which means H plus goes from +1 to 0. So that means that H plus is reduced. It has to gain electrons. It becomes more negative, right, from +1 to 0. Notice how what was listed here are the reactants. The reactants are always what are either oxidized or reduced. And notice that you can't have one without the other. And so then if we're looking at what is the oxidizing agent and reducing agent, just remember that the substance, so in this case calcium, if it's oxidized, it's the opposite agent. So if Ca is oxidized, that means that it is helping H plus be reduced. So Ca is the reducing agent, H plus is the oxidizing agent. So what I want you to do is take just a second and pause the video and see if you can work through example 2 on your own, and then come back to the video and check your answers. So if we look at example 2, we are assigning oxidation numbers, and then we are still looking at what is oxidized and reduced, as well as what each agent is. So iron 2 plus goes from +2 to +3. And so since iron goes from +2 to +3, it's becoming more positive, so it has to lose electrons. So Fe2 plus is oxidized, and then Cl2, so Cl2 is elemental chlorine. Cl2 will go from 0 to -1. So Cl2 is actually reduced. It has to gain electrons to go from 0 to -1. And then since Fe2 plus is oxidized, that means Fe2 plus is the reducing agent, and Cl2 is reduced, so Cl2 is the oxidizing agent. Check number 2 says determine if each of the following is or are redox reactions. So we have 3 reactions here. We need to figure out if they are redox or not. And so to determine if they are redox, we have to first assign oxidation numbers. So you want to assign oxidation numbers to everything. So if we're looking at A, we want to assign oxidation numbers to every individual element in this reaction. So if we go through, potassium is always +1. Group 1 and group 2 metals are always +1 or +2. So K is +1. So each K is +1. Chromate, CrO4, altogether is 2-. That's why we needed 2 Ks. If we think about CrO4, oxygen is always -2 unless it's with fluorine. So each oxygen is -2. That means that Cr has to be +6. So we have +1, +6, -2. That's each individual. Ba is +2 because it's in group 2. Cl, each Cl is -1. If we look at the product side, we have +1, -1, and then we have +2, +6, -2. So each of these oxidation numbers stays the same. Since they stay the same, it's not redox. So A is not redox. B, Pb2 plus is +2, Br minus, that's -1. These are ions. So since these are ions, the oxidation number is the same as the charge. So +2, -1. And then if we look at PbBr2, each Br is -1, Pb is +2. So these oxidation numbers from reactants to products do not change. Therefore, B is also not redox. And then finally for C, we have elemental copper and elemental sulfur. Notice these are not ions. These are elements. So copper is 0, sulfur is 0. When we look at this side, S is 2-, Cu is 2+. And so these oxidation numbers change. Copper goes from 0 to +2, sulfur goes from 0 to -2. C is redox. So what I want you to do is actually go through check number 3 and check number 4. So pause the video. I want you to go through. I want you to see if you can do 3 and 4 and then come back and check your answers. So when we're looking at which substance is oxidized in the following reaction, again, assign oxidation numbers first. So Cu is 0, S is 0 because they're elemental form. Then we look at Cu is +2, S is -2. So we're looking at which one is oxidized. So copper goes from 0 to +2, sulfur goes from 0 to -2. Remember that oxidized means that it loses electrons. So it's becoming more positive. So Cu is oxidized in this reaction. When we're looking at which substance is oxidized in this reaction, so again, assign oxidation numbers. Ca is 0, right? Fe3 plus is Fe +3. So we have 0, +3, +2, because it's the same as the ion, and then elemental iron is 0. So which one is oxidized? We're looking for which one loses electrons, so it becomes more positive. It's going to be Ca. The reactants are always what are either oxidized or reduced. I want you to see if you can go through check number 5 and check number 6. Pause the video and then come back and check answers. So for check number 5, it wants us to go through everything that we did before. So assign oxidation numbers, which is oxidized, which is reduced, and then reducing agent and oxidizing agent. So when we look at all of the oxidation numbers, so remember that H, if it's with a non-metal, is always +1. So if H comes first, it's going to be +1. So each hydrogen here is +1, sulfur is -2, Cl2, that's elemental chlorine, right? Diatomic chlorine that has an oxidation number of 0. So we have +1, -2, 0. Each hydrogen is +1, chlorine is -1, sulfur is 0. Notice that hydrogen doesn't change, so hydrogen is neither oxidized nor reduced. What does change is sulfur goes from 2- to 0, and chlorine goes from 0 to -1. So which element is oxidized? So we are looking at which element is losing electrons. So when we look at which element is oxidized, is losing electrons, we're looking for the one that becomes more positive. So S goes from -2 to 0. So sulfur is oxidized. Which one is reduced? So which one gains electrons? Cl2 is reduced. Cl2 goes from 0 to -1. The reducing agent is what it gets oxidized. So the reducing agent, this entire substance is the reducing agent. So H2S is the reducing agent because that contains the element that is oxidized. So H2S is the reducing agent, Cl2 is the oxidizing agent. So for check number 6, so the last example looking at assigning oxidation numbers and oxidation and reduction. So if we look at assigning oxidation numbers, so let's start with oxidation numbers that we know for sure. So we know that Cl is almost always -1. So each chlorine here is -1, each chlorine here is -1, each chlorine here is -1, and here is -1. Tin and mercury, those oxidation numbers can change. So tin here, we have 2 chlorines. That means that Sn has to be +2. -2 total, Sn has to be +2. So now we have +2, -1, and then this Hg also has to be +2. So now we have +2, +2. Tin here, if we have 4 chlorines, tin here must be +4. So tin is going from +2 to +4. Now mercury is a little bit different. Mercury 1 is actually Hg2 +2, which means each individual mercury is +1. So mercury goes from +2 down to +1. So which element is oxidized? So we want to look at which number gets more positive because it's losing electrons. So tin, Sn, is going from +2 to +4. So Sn is oxidized. Hg is reduced because it's going from +2 to +1. The reducing agent, so remember that the agents have to be the entire substance. So reducing agent contains what is being oxidized. So the reducing agent is SnCl2. The oxidizing agent is HgCl2 because that contains what is being reduced.